Hi guys, once again another video. This, as you might remember, I said I'll be producing a series of videos on the QRH, and of course it's taking a bit of time because I'm very busy with flights, and making videos regularly is sometimes becoming a challenge. However, whenever I find a bit of time, then I can just sit down and produce some sort of tutorial for you to understand in my way, in the simplest possible way. And then of course any comments and criticisms are most welcome. We all learn from each other anyway as we go along. So here's another part 3 for understanding the QRH. I've done the first 2 parts, and I think in each part I did say, if I didn't, that please make the QRH as just like what people would say it in a figurative language, make it like your Bible, so that you read it every single day. Okay, it's very important that the QRH of any aircraft that you fly should be read almost every day, so that in case you have to apply anything from the QRH, regardless of the aircraft you are flying, whether it's a King Air right up to an A380, you just need to know at least quite a bit, a bigger portion of the emergency procedures that you may face, although most of them are so remote because of the advanced technology and everything that has been accommodated to make our aircrafts very safe. However, emergencies do arise, and when an emergency arises, as much as the QRH is divided into memory items, which definitely have to be committed to memory, there is no doubt about that, which let's say in the Bombardier Q400 that I fly, they are boxed. In other aircraft QRHs, I think some of them are also boxed. Those are meant to be committed to memory. However, those items which are not meant to be committed to memory should be read and read and read until they are somewhere in your memory anyway. So at least you know you're ahead of the game. In case something comes up, you know after you have executed the memory items what's going to come next. That is for you and yourself to know. Okay, you will definitely call for the QRH after you face an emergency or an urgency or a fault. You will call for the QRH if there is a memory item. Before you call for the QRH, you will execute the memory item, then you go for the QRH. Nonetheless, it doesn't mean that, okay, I just have to commit myself to memory. The other things, I will just get them off the QRH when a situation arises. That is not the correct way of thinking. The best way is to go chapter by chapter. You read the aircraft flight manual, the FCOM, and then the QRH. You relate them together, you integrate them together so that you have a complete set of literature in your mind regarding a particular system. And the QRH, I always, every morning when I wake up, of course after I've done my rituals and my prayers and all that, I will sit down with the QRH and I'm going to go chapter after chapter, just to keep my mind fresh in case I'm facing any caution, warning, or anything. I know exactly what the coach will be saying, although I'll be commanding for the QRH to my first officer if need be. Okay, so make sure the QRH is taken as a very, very important manual. Of course, all of them are important, but the QRH will definitely keep you ahead of the game in case something happens. Okay, don't rely on the notion that memory items have to be in the memory, and the others I'll just read them when after I finish my memory items for a particular fault, and I'll just get them read and do as the QRH says. That's not the way to do things, not to me. Okay, I prefer the QRH to be in my memory, in my head. Okay, so that at least I know when I see an oil temperature rise, or when I see a hydraulic problem, or when I see a DC bus problem, or anything, I know what the QRH should be telling me to do before it is even read by the pilot monitoring. Okay, this is my advice to you. Please take it seriously. Keep the QRH close to your heart as you do with other manuals. So we're now going to investigate again every part of the electrical system, messages and cautions, just briefly talking about what they mean. Some of them are pretty obvious, self-explanatory, but some we can just talk about and understand. And I'll even show you on the simulator, the Majestic simulator that I normally use for some of these demos, what happens when I will intentionally switch off the let's say for example the AC and DC gens, and then we can see what cautions come into view. Of course, we will never ever do this in reality in a real aircraft. You'll never do this in the proper level D simulators that we go for our recurrent training every 6 months. We always get these type of faults. They can do that, but we never ever demonstrate these things in the real aircraft because it's not practical. It's very unprofessional to start switching off things when they're not meant to be done. Okay, so here for explanation purposes we'll just see one or two things and then we'll take it from there, and that will be this presentation done until the next one when it comes. So let's go ahead and look at the QRH. Okay, guys, here's the QRH section to do with the electrical system of the Dash 8 Q400 aircraft. So what we have here, there's a list of contents. Loss of main DC bus power, main DC bus failure, where there is no DC bus caution light, then you can have a DC bus caution light, and then the like, okay, which is just a matter of you reading through. Our job is now to go through each of these where we need to explain what to do and what we can observe when we actually do get some sort of caution in this regard. So let's go ahead and get started on that one and see how much we can cover as we go along. So the first page after the contents will be a schematic of the DC power system, and this isn't that terribly difficult to understand. It's quite, I just want to make it straight so that at least we know what we're looking at. I just don't want to go out in circles here. So here it is. It looks something like this, the DC bus schematic, and you have 3 buses. A bus is just let's say your spine. Okay, your spine is your distribution bus in your body, where all the nerves are located, okay, and all the signals are passed to the brain. Okay, so a bus is basically like a bar where all, in simple language, where all contacts and connections are made, from where the necessary power or voltage or current is distributed to the relevant systems. Okay, and in this aircraft you have 3 buses: the essential bus, then you have the main bus, and you have the secondary bus. So the essential buses, the main buses, and then the secondary buses, and each of these buses power certain components in the aircraft. Not to go into too much detail because most of it can be obtained from your AOM and other softwares, CBT softwares that might tell you. Even in the QRH there is some sections that you will see where they list the services that can go off when a particular bus fails. And so basically this is a schematic. You have the switches here which are drawn, and then these, what you see here, these are called the bus tie contactors. Okay, they switch on and off depending on how the EPGDS, if you remember from your AOM, the electrical power generation distribution system, configures the aircraft when a particular bus fault is detected. Okay, so that one bus, if it fails, the other bus is very much able to power those components of the failed side, okay, by closing what you call the bus tie contactors, so the 2 buses can now be connected together. In normal operations they are open, but they will close if one bus fails so that the other bus can power the failed side. Okay, but in normal operations the contactors are always open so that each bus is powering its side. Okay, so if you read the AOM, it's a very simple layman's words. If one bus fails, it sends a fail message to the operating bus, which will then be detected by the EPCU, the electronic power control unit, which is a computer. It will close the necessary bus tie contactor, and then it will allow the operating bus to power the components of the failed bus. Okay, so and it's quite a tolerant fault tolerating system, which you will read most of it in the AOM. Okay, so I'm going to get this page back into straight format now, and then we can continue. That's the DC bus schematic. You also have the AC power schematic, which is here. Okay, and basically, if I don't straighten this up for now, it just shows, if you see these cross connection here, it just tells you that once one bus can power the other bus, and the AC buses can also power the DC system as well. That's how good the electrical system in this aircraft is, and it's really interesting to know that. Okay, and then you have got some caution lights here, which come on the caution and warning panel, the CAUP you call it. Okay, and the like. So without going very much in detail on those circuit diagrams, let's try and now start the contents of the QRH. So the first one here says loss of the main DC bus power. So if the whole bus, a particular bus, either the left bus or the right bus, the whole thing fails, what are you going to note? You will definitely note that the autopilot and yaw damper have disengaged, so the aircraft has to be flown manually. Now, the other thing about this is to do with both left and right DC buses. There are some common items like the autopilot and yaw damper. Then there is a stick pusher, okay, which is very important. For the left main DC bus, one other thing which will cause you to be in a serious situation is a pressurization, because the pressurization system is powered by the left side, left main DC bus, and when the left main DC bus fails, the aircraft will depressurize, as you will see in the upcoming items. Okay, and this tells you that, okay, I need to go down, you have to descend. Or if they fail before you reach, let's say, 14,000 feet, you stop the climb. As easy as that. You don't want to continue climbing with this situation for obvious reasons, because you don't want to go into an unpressurized regime. You'd rather be low at a safe altitude where you can come back and land after you've solved the problem, or if you've completely solved the problem, then you monitor, you contact your operations, your maintenance rather department, and operations as well, to seek their advice, and it all boils down to a proper teamwork sort of management system. Okay, so you have all these things. I have actually memorized all these, okay, and I would prefer everybody do the same thing. Okay, you just need to memorize each and every item here. You can form mnemonics. I normally form mnemonics. For example, it might sound funny, but if you look at this, the first letters of each of this, I can say it's AA, cell, roll, PEF, W. So I know what I want to look at here. That's my way. I mean, everybody's got their own ways. And here you can even see the first letters will be like ASARP, and then I just say DCRC, PTV, F, and then C. And then I can just know what I'm looking for. So the human mind can also be programmed to memorize things in that way as well. So at least I know off by heart, if I lose the left main bus, main DC bus, or the right main DC bus, what things won't be working. So on top of my head, I know I'm not going to get ABC, for example. Okay, very important. Now, the next one is the main DC bus failure. Now look at this. It's a DC bus failure, meaning you will not have any caution light on the CAUP. Okay, so there will be no ding, one of those chimes. It won't come. Okay, means there's no DC bus caution light. So then you just have to know what you have lost. So if you lose a left main DC bus, okay, it will be the left side of the system that will be gone. So this is basically all these. All those will be gone. If you lose a right side, all these will be gone. So at least the system that you've lost will indicate which bus has failed. Okay, and then you go to the electrical systems page on one of the MFDs. Okay, and then you confirm that the load is 0 on the DC Gen 1 if it's a left main DC bus. The auxiliary load, battery load rather, you have to confirm it's negative, and the DC Gen 1 has to go off. Once it goes off, confirm all lost services are restored. Okay, if they are, all good and well. If not, then you follow the rest of the items. Again, if you lose a right main DC bus, the same thing, the right side systems will be lost, so it will be all these here. You will not get all of these. Okay, so it will tell you, okay, I've lost a right main DC bus. So that's what I'm saying, is that if you memorize those items, at least you have an idea which bus you have lost if it's a DC bus failure. Okay, and then the rest of the items are just completely similar, especially the main DC battery load is a bit different because that's the right main DC bus now. Confirm it's negative. This time it will be DC Gen number 2. Remember, it's a right main DC bus. You put it to off and then you see what's happening. Okay, so that's very important. The next thing which comes is a DC bus caution light. Now remember, that one was a DC bus failure. Here you'll have a DC bus caution light, but you can also have a DC bus caution light when you have a main DC bus fault. Can you see the difference here? This is a main DC bus fault where there is a caution light. This is a main DC bus failure where there is no DC bus caution light. So in your training and even in reality, don't get confused. This is a very simple yes and no item. If it's a DC bus caution light, you're going to get one chime ding on the CULP, okay, and then you see, okay, I've got a DC bus caution light, so you're going to say DC bus caution light checklist, and then the checklist will be red. Other associated caution lights are omitted. If it's a yes, then you're going to go to this checklist here, main DC bus fault caution light. If it's a no, that's when you're going to press the reset switch and see whether the caution lights have gone. Okay, so basically this is it. So this one here could lead you into this or maybe not. In this one, main DC bus fault. Okay, so if it's a DC bus fault, you will have the DC bus caution light, and then if it's a left main DC bus, it will be number 1 DC Gen caution light, the standby battery caution light, and the aux battery caution lights, because these are according to left main feeder bus, according to the system's knowledge that you might have. Execute all these items the way it is, okay, and then once you've done it, you go to a yes and no yes and no area. Okay, so DC bus caution light remains illuminated. If it's a yes, it tells you that, guys, let's go down. If you're high up there, let's descend, because the aircraft will pressurize. So no panic, you just have to descend the aircraft into below 14,000 feet. Okay, and you execute all these items. Okay, then it says here, land at the nearest suitable airport. Now can you see this one here? If you remember from my earlier videos on the QRH, we actually emphasized these phrases which are in the beginning of the QRH. Here it means that you may continue the flight, okay, or divert or return back depending on your assessment of the situation. Okay, at 14,000 feet or 13,000 feet, the aircraft can still fly. Okay, terrain not being a factor, obviously. Okay, you can fly, and then you can ask for whether you'll continue, you divert, or you come back to destination depending on how far you are. Okay, it's all up to the crew's discretion. Normally it boils down to the captain's discretion. Okay, so you'll continue if you know, okay, if I land there, is the weather good? Yes, it is. Do I have maintenance facilities where I'm going? Yes or no? And based on those criteria, you will then make a decision. Okay, you don't want to go to an airport where there's no maintenance facility, you've got a fault, and the aircraft just remains grounded in that particular destination. You don't want to do that. Okay, so all these factors have to be taken into account: the weather, maintenance facilities, and the like. Okay, so you think of lots of things there: company impact, passengers, and the like. That is what you call decision of that captains have to make. Okay, most of the time. Okay, so when you have put the aircraft below 14,000 feet, you have to ventilate the cabin, and therefore you just have to execute these items, and then remember that you can, if the speed is above 150, which normally it would be, then the ram ventilation, ram meaning it's ramming, meaning it's hitting the aircraft from into the NACA vents on the dorsal fin, entering the aircraft. So the faster you are going, the more air is being rammed, hit into the system. Okay, and then you refer to loss of main DC bus power checklist, which we just saw early on. That is if these DC bus caution light remains illuminated. If it does not remain illuminated, okay, monitor the DC bus faults and generator loads for normal indications. Now you can see this part of the QRH is one where the revised electronic control system logic is not incorporated. Okay, so that's very important. So I've gone through this one. We'll see how the difference is between this one and the other one where it is incorporated. Okay, right main DC bus fault, basically the same, only that it will be DC bus again, caution light. This time we'll have a number 2 DC gen and the main battery caution light. Again, execute these items, and then it says leave selector switches in the off position. Okay, so what I'm trying to say, guys, is that if you read and read and read these QRH items, you will not forget some of these little things here which mean a lot. Let's say like leaving the selector switches in the off position, because sometimes people may go and put them on again just out of instinct or something. Okay, human error is always there, but since you still are reading, you will know what you are doing. Okay, DC bus caution lights remains illuminated again. Now here it says the same thing. All right, and again you just have to actually follow all this, pretty much self-explanatory. I don't need to go bullet point after bullet point on this. Landing distance factor, basically you multiply these numbers by the landing distance that you have, unfact landing distance, to see if you are still within the required landing distance of the aircraft, depending on which flap setting you're going to use. Okay, and again this is revised ACS logic not incorporated. Now we are going to go into the same checklist, okay, but this time I think it's going to be the revised ECS logic is incorporated. So here we go, the same layout here, no difference here, but here there is a difference. Okay, if you see the DC bus caution has been illuminated, yes, it says note, automatic cabin pressure control is lost. The fault advice light on the pressurizing control panel will be illuminated. Now on the same one here, where there was no revised ECS logic incorporated, let's go and have a look at that. Can you see there? That's not what it says here. Okay, because this one does not have an auto cabin pressurization area. It just says ECS pack airflow is lost and cabin will depressurize. That's all it says here. Okay, so here it tells you descend. Okay, and if you look at the same section, but where the revised ECS logic is incorporated, okay, here it says auto cabin pressure control is lost. You will have the fault advice light on the pressurizing control panel will be illuminated. Then you do the depressurization maneuver, okay, and you go ahead and descend, and if needed you land at the nearest suitable airport. That's where the difference comes, if you can see what's happening. Okay, and the same thing here. Okay, there isn't I don't think there's much of a difference here to the one up there. The only difference was about the pressurization, what happens to it in which system. Okay, so that's that. And now we go to loss of AC bus power. Okay, so here are all the systems that are connected to the AC buses. The left AC bus powers these, and the right AC bus powers those. Again, as I said, that I like memorizing, if I can, quite a bit of it. So here I could memorize, I can see they're very much similar. Auxiliary fuel pump, prop de-icing, alpha vane heater, and so on and so forth. Now what I've done here, I've also done my mnemonic. For those of you who love memorizing through mnemonics, I can read the first letters, not the L's and the R's, but the first letters of the names here, and it reads like Apati Pe, A-P-A-T-I-P-E, and I can even see here A-P-A-T-I, and then there's a P and the E here with some add-ons. So after APATI, I have the pilot winch, the pitot static heater, and the engine intake heater. Here also have the pitot-static heater and the engine intake heater. But the add-on here is a pilot windshield heat, norm and warm-up, and the add-ons here are the standby hydraulic pump, the co-pilot windshield heat, norm, and the pilot side window heat. So the Apati pay is in all of them, both of them, with the add-ons that you can just memorize and put them into your list. Okay, that's the way I do things, guys. So at least I know what I'm looking at. Okay, that's my system. You might have your own system. Okay, now we continue looking at what happens when the AC buses fail, one or the other. So here it says left AC bus or right AC bus. Okay, and what happens here is pretty much simple. You just have to follow what is actually happening. All right, stick push shut off will come on. You have to press it off. Airspeed has to go to VREF for the minimum airspeed. And then it says, because if AC buses are controlling the icing system, all right, you have to maintain the airspeed appropriate for icing conditions and other fields if applicable. Fuel transfers won't be happening. The windshield heat affected won't be demisted or anti-iced. And then it just tells you guys, just be out of icing conditions. Okay, so if you know that ahead there is icing and clouds and all that, you don't have to be in that situation, because it's very much obvious. There will be ice buildup on the airframe. You'll not be able to melt the ice down. The airflow will become rough. The aircraft may not be able to sustain lift and flight rather, and then you end up in a stalling situation and some other nasty ones that you don't want to talk about and even think about. Okay, so it's very much obvious that just get out of the icing. Okay, and then you look at your speed indications. Basically, if the speeds are not consistent with the standby speed indicator, you use your AFIS ADC source and select one or two to match the faulty airspeed indication to the one which is more correct, which is near the standby indication. Okay, that's very important. Okay, and here is a bit again about icing. In short, just get out of icing when you have AC or left AC bus or right AC bus fault. Okay, the next one, now we come here and I will show you a simulation on this one towards the end of right at the end of this QRH explanation, because we are intentionally, as I said in the introduction, going to switch off the gens, AC gens and DC gens, and then we just want to see what caution lights come on and what happens to the displays and what you have to do. I just want to show you that. I'm pretty sure it will be similar or if not the same in the real aircraft if that had to happen. I've never experienced it in the real one, but we normally practice this in the level D simulator when we go for recurrence. Okay, so here it says loss of generated power. This is a serious one. So number 1 DC gen and number 2 DC gen, and either. You can see how much emphasis I'm putting on some important words. And either number 1 AC gen and number 2 AC gen, or the left TRU and or the right TRU. You've got to be very careful on what you're looking for here. So here it does say you will lose both DC generators and both AC generators, or you will lose both DC generators and one or both TRUs. So there are two scenarios here which lead to loss of generated power. Okay, please, before you continue reading this one here, make sense of what it says here, what you will lose. Okay, so it's either you lose both generators DC and both AC generators, or you lose both DC generators and one or both TRUs. Each of these will result in what you call loss of generated power. Okay, then basically it just tells you to execute some steps here. All right, and bear in mind the time duration, because now batteries are the ones which are in action and you have a time limit on the batteries. Okay, since you've lost your power in a very substantial amount, definitely you can say that, okay, I will depressurize as well, the aircraft will depressurize, so you go to 14,000 feet as soon as possible, and then you follow what is saying here, and the rest just becomes like what we have actually read in the previous section. Okay, so very important and a very serious case, which we hope we never even experience in real life, but it does happen, and there have been some accidents which have taken place because of electrical failures. Okay, right. In the next one, now you will lose both DC generators and one AC generators rather. Okay, both DC generators and one AC generator. Okay, so when this happens, all right, it says land immediately. Can you see that? Not land at the nearest suitable airport, but land immediately, meaning in this case, guys, come back if you're near the departure, divert immediately to a suitable departure, alternate aerodrome, or if you're near the destination, go and land immediately without any delays. Okay, that's very, very important. Simply because you have lost both these generators, and when one AC generator, it means you are in a serious situation. I'm pretty sure that in this case it also says land immediately. You see that? So this is loss of generated power is also saying land immediately. Okay, very much obvious. If you lose electrical system in this much amount, you don't want to be hanging in the air there and doing nothing. Okay, you have to get down. All right. And now another scenario is where number 1 DC gen and number 2 DC gen caution lights. Just remember that when these caution lights come, to avoid ambiguity, call for the appropriate checklist. Okay, don't use any other phraseology or wording. As it says here, call for that particular checklist. For example, if you have a DC gen, 1 DC gen, 2 DC gen caution lights, you will say number 1 DC gen and number 2 DC gen caution lights. That's the reason why I'm saying always read the QRH, so you even know how to call out for the appropriate checklist when a certain situation arises. Okay, so when you lose both AC generators, you will switch them on and off just to like recycle them and then check what's happening. But here there is nothing about landing. Of course, you lose a couple of items, okay, but the aircraft will still fly. Okay, very important. And then here you have number 1 DC gen or number 2 DC gen, so one of the two, but both TRUs. Okay, again, it's not an issue. Okay, the secondary buses will be inoperative, so you lose some items. Okay, but then you can either come back, or you can continue, or you can divert, depending on what you and your maintenance station at your base decide. Okay, any decisions you take, make sure, of course, as much as the captain has final authority, but a collective decision is a good CRM method. Here, the simplest one, you can lose 1 DC gen, either number 1 or number 2. Okay, here it just says switch it off and on. Okay, and then it's a yes and no. If the caution remains on, switch off the generator. If not, then just monitor the affected DC bus volts and generator load for normal indications. Okay, you won't have any issues, just switch it off, that's all. Okay, now you have something to do with generators becoming hot, so either one of them becoming hot or the other one becoming hot. Very simple, it just says switch off the generator. Okay, and it does say here continued operation of the associated engine is permissible for the remainder of the flight. The affected gen hot light may remain limited for the remainder of the flight, so you don't need to worry about it. It's pretty much okay, just switch it off, and that generator has been secured and isolated. You can also have both AC generators coming faulty. Okay, so it will be both of them caution lights coming on. All right, and in this case, just remember, if it's about AC generators, your main concern about icing. If you're in icing conditions, clouds and the like, get out of it immediately. Okay, and then obviously you're going to check if your prop selector is off, your condition lever should go to max. Okay, so you produce more revolutions, okay, per minute, and then you recycle the switches and then you check what's happening. Okay, and in this case, if it's one of the AC gens which come on, call for the appropriate checklist. Off then on, yes or no. Okay, and it's just as simple as that. And then you have the hot part where the generator becomes hot. Again, it's just similar, or if not the same, to the DC gen hot. Okay, where you just switch off the generator and isolate it. Okay, if it's a TRU caution light, left, right, TRU, or you have a TRU hot caution light, left or right, that's not an issue. Just locate on the right hand side upper CB panel for the particular TRU, pull it, isolate the TRU, and it's all good and well. Okay, so I think that covers the whole of, not really, just almost the electrical part of the QRH, and now we're going to go into the battery section. So if you get a main battery or aux battery or standby battery caution light, here it's just switching off the battery, and then it's a yes and no. If the light remains on, switch off the battery. If not, monitor the affected battery load and DC bus loads on the electrical systems page of the MFD. Okay, but now if you get a main battery, aux battery, standby battery hot, caution, that's a serious one. Remember, the batteries are in the nose section of the aircraft if an APU is installed. Okay, the standby battery will normally be in the tail section if the APU is not installed, but with an APU installed, all three batteries are in the nose section. And in the nose section, you also have the oxygen cylinders. And oxygen and fire are not a very good combination because it just leads to an explosion. Okay, now if you have a main battery hot, aux battery hot, or standby battery hot, caution, warning light rather, it's a warning light as well. You have to be very careful because you may end up in a situation that you don't want to be in. Okay, and here it says land immediately at the nearest suitable airport. Land immediately. It's for obvious reasons. Okay, it has to be of a very big concern to you. You don't want to have any battery exploding which is near the oxygen cylinders. Okay, emergency lights disarmed, caution light, basically not a big issue at all. Just put the emergency light toggle switch to the arm position and that caution light will go off. Okay, this is the end of the electrical system electrical system side of the QRH. Now what I want to do is that I just want to go all the way to the beginning, and we just want to talk a bit more about could we or shouldn't we reject if any of these lights, let's say, came on the takeoff roll. Okay, so I want us to see that as we just briefly visit these items. Okay, quickly then, let's say we are doing a takeoff roll and we have a DC bus caution light coming on the takeoff roll before 80 knots. Would you reject the takeoff? As it is, different schools of thought give you different opinions. Some would say take the aircraft airborne, deal with the situation, come back and land if it doesn't get resolved. Some will say, well, if it doesn't get resolved, what's going to happen? We have to come back and land anyway. For a DC bus, I personally would reject the takeoff. Okay, because it's a serious one. It's a whole bus which has gone. Okay, and I don't want to go in the air knowing that my whole bus has gone. Okay, it could be a recycling item where after you recycle it may go, but I cannot predict on that one. Okay, so instead of me taking the aircraft into the air and maybe it won't fix itself, I have to come back and land. So the buses to me look like I'll definitely do a reject. Okay, let's say you are in takeoff roll and you get number 1 DC gen and number 2 DC gen and all these, immediately you reject. You don't want to go into the air having all these caution lights coming on. I mean, I wouldn't actually, for safety reasons, I wouldn't even take off. Okay, I would reject. Okay, that's before 80 knots obviously. If you have both of these coming on, DC gen and number 1 DC and number 2 DC gen, well, here I wouldn't reject. I would take the aircraft into the air. Okay, it's only 2 of them. I would execute the QRH items. I wouldn't go past the MSA and see if it fixes itself. If it doesn't, I'll come back and land. Okay, so this one is, to me, is not like something that I have to actually abort the takeoff. How about number 1 DC gen or number 2 DC gen? And so 1 DC gen and both TRUs. Again, this one has got quite a few caution lights, so it isn't that serious though. Looking at the items, I'll still go into the air and I'll actually try and resolve it using the QRH and see if it works out. If it fixes, then I'll continue in consultation with the maintenance department. Otherwise, I'll come back and land. Here, if you have one DC gen caution light, you don't have to reject at all. Okay, it's just some you can even recall that it's an on-off situation. So if you switch it off and then on, if it remains, well, it just switch it off. Okay, and you can continue with one DC generator. It's not a problem. Okay, if you have a DC gen hot or DC gen hot, number one DC gen hot or number two DC gen hot caution light, it's again one caution light coming on. I'll still go back into the air. I'll still take off, continue to take off, okay, and I will see what the QRH item says. Is just switching off the DC generator resolve the problem, and I'll be okay. Again, I'll contact the maintenance department. I'll not abort on this one. This one again, I wouldn't abort, but I don't want to also be in icing situation. So I can get both of these coming on, but I don't want to be in icing situation. I will go up, I will resolve it if I can using the QRH. If not, then I'll come back and land. Here you only have one AC gen. Again, it's not an aborting takeoff sort of thing. You don't have to reject. You can go airborne, resolve it. If it happens, all good and well. If it doesn't, well, you can still continue with one AC generator. Okay. The hot part, the same as the DC gen hot part. Okay. And this one, if you have any of these coming on, you can recall immediately there's just a CB item. Okay, that's the reason why I say that if you read and reread the QRH, some of these they just become committed to memory. Okay, if you have a battery caution light, any of the three batteries caution light, again it's an on-off situation. Resolve it, take the aircraft airborne, resolve it, and see what can be done. Okay, but if you have a main battery hot, aux battery hot, or some battery hot warning light, it's a serious one. It's a warning. Okay, so if it's a warning, it tells you no, I'm not going to go with a warning. So personally, I would not take off with this one. Okay, because it's a serious thing. Okay, I don't know how much the battery is boiling. Okay, before it explodes, hits the oxygen canisters, and then we end up in a situation we want to be in. Okay, and this is just self-explanatory. I don't need to reject a takeoff just because I had an emergency lights disarmed caution light. There's no point in that. Okay, so decisions to reject the takeoff or to continue depends or differ rather depending on the crew or the captain. Okay, some would say it's okay, some would say it's not okay. As long as you are playing it safe, okay, as long as you are safe, okay, the aircraft is kept in one piece. Whether one person decided differently than you, but both of you kept the aircraft safe, the asset of the company is safe, you are all okay. That's my perspective. Okay, some people say yes, some people say no, the same thing, but safety should not be compromised. That's the whole that's a moral of the whole story here. Do not compromise safety. Okay, so having done that, I've gone through this electrical part of the QRH. I just want to show you now on the simulator when I intentionally switch off these DC gens and AC gens. We just want to see what actually happens. I'll talk you through, and then that's about it for this part of the presentation. I hope you've understood what I've said. Drop comments, criticize whatever you think is not okay, and definitely it will be good for me to learn as well. Thank you so much. Let's go into the simulator and do one little demonstration. Alright, here we are maintaining 24,000 feet cruise altitude. Okay, and all I want to show here is that intentionally we'll just drop all the DC gen switches and the AC gen switches, and we just want to see what happens on the culp and the displays. Okay, it's a very short presentation because there's only one thing you'll have to do. If you read from your literature, the PFD1 can be transferred to the MFD1 using what you call this switch here, which changes the PFD to MFD, which is this one. Okay, so your MFD1 switch, you'll switch it to PFD. Bear in mind, I haven't set any frequencies or any other minimums and all that, because that's not the purpose of this presentation. Here we just want to see what happens when we actually lose all the electrical power. So intention I'm going to do, I'm going to go overhead. Okay, I'll go overhead. I can just put a bit of the volume up here, so at least you might be able to hear the chimes. And let's try this and see if it does give us some sort of realistic picture on what actually would happen. So I'm going to switch off rather, the DC Gen and the DC Gen 2 portion, switches, and that brings, as you can see, the number one DC Gen caution light and the number 2 DC Gen caution light on the COP. Okay, and now what I'm going to do the same thing. I'm going to switch off the AC gens. So the AC gens are here, so I'll switch this off. I'll switch this off as well. Okay, and now you can see what has happened. It's quite terrible. Okay, we have all these lights which have come through. Icing system lights have come through, and there we go. You heard that chime there? That chime was the autopilot has got disengaged. So you see from the QRH what it was saying, autopilot your damper will disengage. Okay, so you can see that LTRU, RTRU, all these lights have come through. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. There must be one more coming here, maybe 16. And look at this, the fault light on the air conditioning panel has come as well, indicating that the aircraft will depressurize. In this situation, you have to start thinking of descending to 14,000 feet, respecting your grid morals and the like. Okay, very important. So I'm just going to pan this again and just see what has happened. Now look at this, guys. All the displays have gone blank. Okay, you can clearly see all the displays have gone blank. The autopilot has disengaged. The aircraft is turning. Okay, and how do I know it's turning? Because I still have the standby instrument. It's turning to the left as it is. It should maintain level flight by the simulation. So you do know that we do have some sort of glitches here and there. And all these displays on the first officer's side have also gone blank, and we don't have any displays. So in this case, what you do when this sort of things happen, what you do, you go to the MFD selector on the number 1 side and you switch it to PFD. Okay, when you do that, you are going to bring the PFD indication on your MFD. So it's only the left hand seat pilot which will be able to control the aircraft in this case, and of course it should light up, and we don't want to be going out of control here. So if I can just control this aircraft again, okay, and then it will start descending. So basically what happens here is that I've just popped this up. Don't bother about all these things here. Of course, in the real situation, the aircraft is much controllable, as you'll appreciate. So that's what I want to tell you, that even this display here, you see it's a bit like still visible, but in reality it should be dark like this one here. So the first thing you do when you see this sort of situation is that you immediately transfer the PFD1 to the MFD1 using the MFD1 rotary selector switch on the ESCP, which is here again. Okay, immediately you take this and put it to PFD, as you guys also have done here. So it was in nav initially, now it's gone to PFD. So you've transferred the PFD 1 onto the MFD 1. Okay, that's what I want to show you. We won't go into any other maneuvers. Of course, you'll have all these lights flicking here and there, which will cancel. Okay, once everything overhead comes up here. Okay, so very important. Here we go. You can see it's depressurizing. The cabin is depressurizing, so you've got a cabin pressure only light as well coming on. Okay, telling you that, okay guys, don your oxygen mask and prepare for a drift down to a low altitude, 14,000 feet, because you're going to depressurize. Okay, and that's basically about it, guys. So I really hope you understand that this is a very, very serious situation. We don't hope for it at all, but if it does happen, control the aircraft first, fly the aircraft. Okay, immediately the left hand seat pilot puts the MFD1 to PFD, so that the PFD information can be transferred to MFD, and with reference to that you can now fly the aircraft all the way down to 14,000, because you'll depressurize, and then you do your depressurization maneuvers and procedures, and land immediately at the nearest suitable airport. That's all I can say as far as I'm concerned. Just a quick one. As you can see that as aircraft depressurizing, look at these gauges here just to tell you what is actually happening. The differential pressure will be decreasing, going to 0. The cabin altitude will be increasing, going quite high. Okay, and the rate of cabin rate of climb will also increase as well. So you can see this is what's actually happening. If I keep the simulation on for a moment, I don't want to lose out of control. Let's just look at the gauges quickly to see what we normally see here, and you will be able to see that it's depressurizing, and then you can have another control course light coming on, and lots of things are coming on here. Okay, as we have faced a serious malfunction in the aircraft. Okay, so that's basically about it for this presentation. Till the next time, stay safe, all right, and always read your QRH with the system's knowledge that you'll be getting. It will save you from quite a few things, because your knowledge level will be quite high in as far as how you deal with any caution, urgency, or emergency for that matter. Thank you very much.